We've all been there. You're deep in the zone, logic is flowing, and suddenly your AI cuts you off. You hit the hidden rate limit, and your entire workflow freezes. For me, it happened during a massive Codebase refactor. I hit Claude Code's usage limits mid-thought for the third time in a single week. I did what any reasonable engineer would do. I rage quit. I pivoted hard to Gemini and decided to make it my entire professional identity, convinced that I could solve any problem with a faster, more accessible model. I set a new hypothesis. If a specialized reasoning model could execute a task, a high-speed generalist model could do it better, as long as the surrounding pipeline was optimized for it. This wasn't a temporary fix. I was stripping reasoning models out of the stack entirely. This was the start of the Gemini-Only Experiment, a stress test for a single ecosystem workflow. I rewired everything. Cursor remained my home base, but the terminal became the Gemini CLI, my cheerful, Google-flavored assistant, ready to generate at warp speed. To get the internet into my stack, I used Apify to scrape sites and Firecrawl to convert entire websites into clean Markdown files that Gemini could actually read. The silent glue was N8N: scrape, clean, store, and commit. Data moved into my code automatically, making me feel like a genius, even when I wasn't doing the work. And at first, it really worked. For generating content, researching documentation, and building boilerplate scaffolding, the setup was flying. Fast generation models thrive on these tasks. They excel when the requirements are wide and shallow, demanding high speed but very little long-term contextual memory. For low-context automation, a fast AI creates a perfect illusion of total workflow independence. You start believing the reasoning models were just slowing you down. Then I opened a massive 47-file Codebase refactor. The illusion completely shattered. Faced with deep complexity, the generalist AI simply lost the plot and froze. It couldn't track how a change in the API layer would break the logic 3 folders away. This is where we hit the intersecting logic retention wall. It's the point where high-speed generation becomes a liability if the model can't maintain the relationship between dependent files. Writing isolated code is easy, but managing this fragile web of 47 interconnected nodes requires more than speed. Specialized reasoning models can hold this complex web in working memory, tracing pathways without breaking the logic. The experiment failed because high-speed generation is no substitute for deep context. When the structure of the entire repository is on the line, memory is more valuable than velocity. I eventually crawled back to Claude Code. I didn't return out of love. I came back because my repositories were broken and I needed a model that could actually reason through the fix. Admitting defeat established a new rule. Ecosystem loyalty is a technical liability. AI tool selection must be dictated entirely by cognitive load, regardless of personal preference for a specific brand. The first half of a modern stack should focus on speed. Pair scraping tools like Firecrawl with a generalist AI for high-velocity, low-load tasks like planning and data pipelining. But you must reserve a specialized reasoning AI for high-load, deep logic interventions, the moments where you need to fix dozens of files at once without losing the architectural thread. We can see this split on a spectrum of cognitive complexity. Scraping and scaffolding cluster on the low end, while architecture refactoring sits at the far extreme, requiring a completely different algorithmic approach. The one-size-fits-all AI is a myth. The modern engineer's value now comes from acting as a manager, delegating tasks to the specific algorithmic archetype best suited for the complexity of the problem.